The next topic in our conversation about number systems are hexadecimal numbers. You'll see hexadecimal numbers quite frequently when you're dealing with digital systems, and that's because they're an efficient way to represent binary digits. So if we look at the chart here, you can see hexadecimal digits, which are base 16 numbers, range from 0 to 9, but then also have the letters A through F included to represent the decimal equivalents 10 through 15. And you can see on the right-hand column, we have the binary equivalents for each of the decimal equivalent and hexadecimal digits. And the nice thing about hexadecimal numbers is they're going to act as a convenient way to represent 4 binary digits. So for example, if we have the binary number 1010, base 2, this is going to be equivalent to 10 in decimal, because if we assign the places here, we have the 8's place, the 4's place, the 2's place, and the 1's place. And so this is going to be 10, base 10. And in hexadecimal, this is going to be represented by A. So you can see here that we only need to represent these 4 binary numbers, we only need 1 hexadecimal digit. And so this is going to offer us a much more compact way to represent really long binary numbers, because now we have one letter that can represent, or number that can represent 4 binary digits. So if we look here, let's do 2 conversions so you can see how this works. So for example, if we're going to convert from hexadecimal to binary, again, this is pretty easy. We're going to take each of our hexadecimal digits, convert it to its appropriate binary representation, and then just append those one to each other. So for example, to convert 4AF base 16, this is also written with this precursor 0x here, which indicates that it's hexadecimal number. We can take each of the hexadecimal digits and separately convert them to binary. So first we have 4 base 16, A base 16, and F base 16. And if we convert these to binary, 4 is going to be 0, 1, 0, 0 base 2. A is going to be 1, 0, 1, 0 base 2. And F is going to be 1, 1, 1, 1 base 2. And to get our final answer, we're just going to smush these all together, and we're going to get 0, 1, 0, 0, 1, 0, 1, 0, 1, 1, 1, 1, and that's all base 2. And if we wanted to do the opposite conversion, to go from binary to hexadecimal, the process is basically just the same. We're going to start on the right-hand side and group our binary number into groups of 4 digits, and then convert each of those groups of 4 into a hexadecimal digit. So we can also see here how to convert to decimal, to something that we have a more concrete idea of from kind of our natural understanding of mathematics. And so if we want to convert this to decimal, we can either convert it to the binary and then convert it to decimal. But if we think about how we would convert a binary number to a decimal number, where we're going to take the value of each location in the number and then convert that, we can do the same thing with hexadecimal. So here we just have to represent the places that we have. So we have the F digit here is in the 16 to the 0 spot. A is in the 16 to the first power spot, and 4 is into the 16 squared spot. So if we want to represent this as a decimal number, we're going to take 4 times 16 squared plus A, which we know in decimal is 10, 10 times 16 to the first power, plus F, which we know is 15, times 16 to the 0th power. If we work all these out, we have 4 times 16 squared is 256, so this is going to be 1024, plus 10 times 16 is 160, plus 15, and so our answer at the end of the day is going to be 1,199 base 10. So you can see that it's, again, pretty straightforward. You're just going to treat each of the hexadecimal digits and multiply it by the value of its placeholder, as we did in this example. So again, another thing you may commonly see in programming languages are the prefixes. It's kind of hard to do subscripts in text files. And so to indicate the base of a certain number, we assume no prefixes for decimal numbers. But if we want to represent a number as a hexadecimal number, we'll use this prefix 0x, which you'll see. And also, if we want to represent a number as binary, we'll use the prefix 0b. And so this is a common way to represent the subscripts that we would use to indicate the base, and is something you'll commonly see in computer programming.